I'm going to look at the next person's submission. We're returning to the idea of a sequence and a series. West Side Modelos, you gave us this question. Okay, it is from the same paper, 2019. It's question 3. It deals with a contextual problem with sequences and series in it, and it deals with sigma. So let's have a look. Question 3. Question 3 said the following. Number 1, 3.1 says, without a calculator, determine the value of the following: of sigma, where y starts at 3 and ends at 10, of 1 over y minus 2, minus the sum where y starts at 3, ends at 10, of 1 over y minus 1. Now, folks, it's for 3 marks. I want to, and it says no calculator. You're not allowed near a calculator in this question. Okay, so what we're looking at is a function with a fraction in it. The y is in the denominator, the other one, the y is in the denominator. If you combine those two, folks, then you're going to work with a sequence that is not familiar to you, first of all. Okay, and you're complicating the answer. You can combine it by just removing this and saying it's that minus that and putting it all on one fraction. But then your sequence will look a little bit complicated for you to not use a calculator. Okay, so let's see. The first 3 terms, it starts at 3. So 1 over 3 minus 1 is 1. Okay, the next one will be 4. Now remember, the sigma symbol means we're adding. So we're going to add a lot of things here, and we're going to subtract the sum of a lot of other things on the other side. So put them in brackets there. If this is 4, 4 minus 2 is 2, so you have a half. Then it becomes 5. 5 minus 2 is 1 over 3. And it will continue until you get to the y value being 10. This is what this notation tells you. Start at 3, end at 10, and plug it into 1 over y minus 2. Okay, so if we put a 10 in there, we have 1 over 10 minus 2, and that is 1 over 8. Okay, so there we have all the terms in this sequence here. There's a minus between. Let's work out these terms. The first one will have a 3. Y starts at 3. 3 minus 1 is 2, so you have a half. Plus, then it becomes 4. 4 minus 1 is 3, so we have 1 over 3. The next one will be a 5. 5 minus 1 is a quarter. And we continue until we get to our last term. What's the last term in the sequence? Well, the y value becomes a 10, and we have plus 1 over 9. Now, folks, if you look at that, you are subtracting things that are the same from one another. Okay, let's have a look. Here, this positive a half minus a half, the halves are going to be taken care of. Positive a third minus a third is taken care of. The next term here would have been 1 over 4. 1 over 4 minus 1 over 4 is taken care of. The term just in front of the 1 over 9 is 1 over 8. You can check it. Put a 9 in there. 9 minus 1 is 8. 1 over 8. Okay, so the 8th is gone. And what am I left with? Look at the poetry here. I'm left with 1 minus a 9th. I didn't touch a calculator. And that was the beauty of this question, is to keep it separate so you can see how things cancel one another out at the end of the day. So here we have 8 over 9 as our answer for those two sums subtracted from one another. Quite a nice question. It looks intimidating if you look at all the sigma symbols right at the beginning, but in case you didn't find this intimidating, you can see how it opens itself up here, folks. and the one subtracts with the other. Okay, let's look at the second question, 3.2. 3.2 reads as follows. Oh, nice one. I'm going to try and draw here. It has a set of stairs. Okay, the stairs look like this. The first one. Now, the initial diagram doesn't have that line on. So let me leave it off. We can put it in later. Then the next stair comes up. These stairs are identical stairs. Okay, so we carry on. And our next stair comes up. And we do the same thing. Oh, my lines are crooked here. Okay, our third step lies up here. And it continues, folks, to 12 steps. So I'm going to work with the first three just to see what's actually happening here. It says the following. This stair is a 3 meter high. It is 5 meters wide, and the depth or the tread on each stair is 2/3 of a meter. So these are all in meters. Now it says, a steep pavilion at a sports ground comprises of a series of steps. There's a total number of 12 steps on this pavilion, of which the first 3 are shown in the diagram. So here's your steps. Now they say, each step is 5 meters wide, a 3 meter high, and then the tread of the step is 2/3 meters in. Now, the open side, shaded on the diagram. Now, on the diagram, this is shaded on the question paper. Okay? That side is open. They're saying they want to put a piece of metal over that. And they want to do it on both sides. So whatever we're going to do here, we're going to do on the other side. So here and there, we want to cover it. They say nothing about the back. So we're not considering the back at all. Calculate the area in meters squared of the metal sheeting that is needed to cover both sides. Okay. Now we can see that these two sides are congruent. Okay. We need to find the dimensions of each one of these. Okay. Now let's have a look. Let's just do this so you can see where it comes from. Our first area that we're going to need here is simply just going to be 1/3 times 2/3. So the 5 meters do not feature here. We're not talking about the tread. It's already covered. We're talking about the side. Okay? So there's one such a block here, and there's another one on the other side. So there's going to be 2 of those to cover the first part over here. Okay? The next one, it's got 2 blocks stacked and 2 blocks on the other side. So the next area here, area 2, is going to be 4 of those thirds times 2/3. So this is the initial value. And I need 2 of them. Now I need 1, 2, 3, 4 of them for the second step. There's 12 steps, remember. So for the third step, I need 3 on this side, 3 on the other side. So the area of the third step is going to be 6 of those little metal sheets. If we cut them in this shape, we'll need 6 of those. Now let's just see what's happening here. The question that they're asking us is, what is the total amount of sheeting needed to cover both sides of that staircase? There's 12 steps. For step 1, I multiplied by 2. For step 2, I multiplied by 4. For step 3, I multiplied by 6. Okay, so what is this? Let's write it in yellow. This is 1 times 2. 1 times 2. The 4 is 2 times 2. The 6 is 3 times 2. So what will area 12 be? Let's see. The 12th area that I'm looking for is made up of rectangles that are this big. And what is it? A was 3, A3 was 3, A2 was 2, A1 was 1. So this here is going to be 12 times 2, which is 24. How's that 24 made up? This 12 and that 12 is doubled to each side. You can see that, then you're fine. Then this question was not that difficult for you. So let us find the actual answer. So the total area of metal needed is going to be, now look at this, I'm going to be very sneaky here. I'm going to remove 1/3 times 2/3. And if I want to, I can even remove the times by 2. What is left? One of those plus 2 of these. Remember, the 2 is removed. The 2 is removed, so plus 3 of those, plus the next one will be 4. And this 2, that, and that is out, so plus 12. Now, folks, you can see this is the natural number sequence that you're adding. You're adding 1 plus 2 plus 3 plus 4 up to 12. It's an arithmetic sequence. So the full sum here will be 4/9, that product, multiplied by the first term plus the last term, which is 12. So what am I using here? I'm using my formula that says n/2a plus tn. Okay, I'm just not writing it down here. Okay, so 4/9 multiplied by that 13 that I have, and that 13 is that whole thing multiplied together gives you a beautiful 1/4 divided by 3 meters squared of metal. Let's just have a look. 4/9 was common. There's 12 terms. So, sorry, this must be multiplied with 12/2, which is 6. So that becomes 6 times 13. 6 times 13 is 78. 78 times 4 divided by 9 brings us to 104.3 meters squared. So that's the number of sheeting that you need to be able to cover both those sides. Folks, that question in totality was for 9 marks. It's from the 2019 paper. It's question 3, and that focused on our sequences and series, sigma notation, and a beautiful application.